All right, this is Mr. Molton, and we're going to look at Activity 1.1.3a, sample calculations related to gears specifically on this video. And one thing I want us to remember is you can always find all the information regarding the PowerPoint presentations for any of these activities and the activities themselves on the LMS. We want to make sure that we always double check that and make sure we're up to date on our review and reading. So this particular example is going to cover example number 1 and 2 on the activity. A couple things we need to know first, though, is that there are some formulas that we have to keep in mind as we go through this. And let me go down here and get a good color that matches my background here. So we'll take yellow. So we're looking at gear ratios. And so there are a few formulas depending on what information we have and what we need to find. So we have the number of gears out, or this is, for example, the number of teeth on a gear, and make sure you see that in just a minute, divided by the number of teeth on the gear in. Okay, in. And that's also equal to the angular velocity, that is a lowercase omega, angular velocity in divided by the angular velocity out. And that's equal to the torque out divided by the torque in. And that's also equal to the diameter out and the diameter in, divided by the diameter in. Now this one is specifically if we're talking about a sprocket and chain or pulleys. Let's say we could calculate that. Belts on gears and things like that. Okay, so these are the, if you've reviewed your PowerPoint presentation on gears like you should have, you should be familiar with this. So this particular problem now states a simple gear train is composed of 3 gears. Gear A is the driver and has 8 teeth. Gear B has 18 teeth, and gear C has 10 teeth. First thing we have to do is to draw this thing. So we have gear A, have gear B, which is a little bit bigger. And these are all meshed together. In other words, they're touching. And then gear C is a little bigger than A, but not as big as B. So this is A, gear B, and gear C. And it says the number of teeth, which is in gear A, which is the driver, is 8. So N equals 8. And this is the driver gear. B has a total of 18 teeth. So N is equal to 18. And C has 10 teeth. So that's the first thing we need to do always when we do our problems, is make sure we sketch this out so we can keep track of where we're at. So the next thing we need to look at is, so this would be problem 1, just to draw this out. So the next thing that we need to do is to actually calculate this thing. So if we say, if the output is at C, this is the output right here at C, what is the gear ratio? Well, so gear ratio is equal to, now what are we working with? Well, it's given us the number of teeth on gears. So this is the formula right here that we're looking at. So number of teeth out divided by the number of teeth in. So let's do some substitution here. So the number of teeth out here is 10. And the number of teeth in from the driver here is 8. So when you do this math, I think this comes up to 1 point, I'm doing this in my head, 1.25, I believe, and over 1, or 1.25 to 1. This is how Project Leadway likes for us to do it. Now, if you actually were to show it 1.25, that would be okay. I would accept that as well. So let's look at an example that would be equivalent to number 3 on your 113 activity. So we're using the same information. So if gear A rotates at 30 RPMs, how fast is gear C rotating? Well, so we're talking about speed here, and that means we're working with angular velocity. Okay, so here's the formula, just as a reminder. Angular velocity in divided by the angular velocity out. I've got a little bit of a delay in my pad here, so sorry about that. Hopefully that's not too confusing. So let's set this up. So our formula is gear ratio is equal to the angular velocity in over the angular velocity out. So what do we know? So I'm going to just round up from the previous problem where I had 1.25, I believe. I'll just round up to make it 2, to make it something easy to work with here. So we know that our our gear ratio from previously was 2 over 1. It was 1.25 over 1, but I've rounded up to make it 2 to make it easier to look at here. So that's equal to our angular velocity in. So we got to look back up here at our problem. It says if gear A rotates at 30 RPMs, well, gear A is the driver, so that's our angular velocity coming in the gear train. So we'll insert that number here over our angular velocity out, which we don't know. Okay, so that is angular velocity. And what is our out gear? It is C. So angular velocity at C. Now to work through this problem, we have to really do some algebra here and get the angular velocity at C, excuse me, all by itself. So let's rewrite this. What would we do? Well, since we're dividing here, if we were to get angular velocity by itself, so we're going to have to multiply by the angular velocity at C. So whatever we do over here, we got to do over here. So let me just set this formula up. So we're multiplying angular velocity over here too. I'm going to drop this down to make it easier. So 2 times the angular velocity at C is equal to, well, this cancels and that cancels. So 30 RPMs. All right, is what we have left. Now we still have to get angular velocity at C by itself. So how do we do that? Well, we're multiplying here. So we're going to divide by 2 on both sides. So when we do that, this cancels and it leaves angular velocity at C is equal to, do this division, 15 RPMs. So this is your answer for the example number 3. It's not the same numbers. Now be careful, don't just go ahead and plug this in. I've just used some different numbers to show you exactly what we're working with here. Hopefully this one has helped you out quite a bit. All right, so moving on, if we look at an example that compares to number 4 on your activity, it says if the output of torque at gear C is 150 foot-pounds, what is the input torque at gear A? Okay, so we're using torque this time, so remember the formula. Gear ratio is equal to the torque out divided by the torque in. Okay, so what do we know if we look at this? Well, we know the output torque is 150 foot-pounds. So let's go ahead and rewrite our formula. We know what the gear ratio is. We know this, and that is 2 to 1. Remember, I rounded the 1.25 up. Let's not forget I've done that. And that's equal to, so that goes like this. That's our gear ratio from our previous formulas, previous calculations. We know our torque at gear C is 150 foot-pounds. And what else do we know? Well, we don't know what the torque in is at A, because it's asking us that question. We don't know that. So we set our formula up finally, torque at A. That's what we're looking for. That would be the N. That's equivalent to N. Okay. So now what we have to do is to work through this, and we're going to isolate torque at A again to get it by itself, so we're going to work through the problem. So if we do this, let's just rewrite the formula. And so we've got 2 over 1, which is our gear ratio, is equal to 150 foot-pounds. We don't know what torque at A is. So to start isolating this, we're dividing over here. This is the operation, and we're dividing, so we're going to multiply by torque at A on both sides. So when we do it, this cancels out and leaves on this side 150 foot-pounds. And on this side, I'm going to rewrite this. This is going to be 2 times the torque at A. Now we still have to get the torque at A all by itself. So we're multiplying on this side, so we're going to divide by torque at A on both sides. When we do this, that's going to cancel out. Excuse me, I've gone astray here, so let me set this back up. Torque at A is equal to 150 foot-pounds. Forget this. Mr. Molton messed up. Okay. So let's go back and remember what we should be doing in our algebra more effectively here. So what we're going to do to get TA by itself is divide by 2 on both sides. This cancels out. And now we have TA all by itself. And that leaves, when we do this division, 75 foot-pounds. Okay, so there's your answer. I'm sorry about my little brain mishap here. Okay, so that's the answer for the example of number 4, and I believe that's exactly the answer that you would come up with in that particular problem. So hopefully I didn't mess you up too much there, and we'll move on to the next one. So an example that's equivalent to number 5 on your activity is this. The compound gear train is composed of 4 gears, A, B, C, and D. Gear A has 10 teeth and is meshed with gear B. Gear B has 20 teeth and shares a shaft with gear C, which has 16 teeth. Gear C is meshed with gear D, the output gear. Power is supplied at gear A with 100 foot-pound of torque and is traveling at 1600 RPM. First thing we'll need to do is to sketch out this particular drivetrain. Want to list a couple of things first that we know. So for gear A, we know a few things about gear A. What do we know? Well, we know that power is supplied at gear A with 100 foot-pounds of torque. So I'm going to list that. We're going to be needing that in our equation as we go forward. The other thing we know is that it's also running at 1600 RPMs. So we'll need that for angular velocity. 1600 RPM. And we're good for now because our sketch is going to take care of everything else. So let's draw this gear train. So here's gear A. Gear B now is meshed with A, and it's much bigger. So I'm going to try to do this and make it look like it makes sense. So here's B. But now we know gear B has 20 teeth, and it shares a shaft with gear C. So how would we do that? Well, okay, so if it's sharing a shaft, then we know C has to be here, okay, because the shaft is running through both gears at this point. That's how it shares it. And then it says C is meshed with D. So let me see if I can do this properly. Here would be D coming out like this. Now, actually, you would not be seeing this part, right? If gear C is meshed with D, that would be, gear B would be behind gear D, and you wouldn't see it. So kind of imagine that. I just didn't draw it properly here. So let's also now go ahead and get our number of teeth. We know number of teeth at A is 10. Number of teeth at B is 20. And number of teeth at C, I believe, is 16. Yeah. N equals 16. Let's put it in proper format. And the number of teeth at D, what did it say? Well, it didn't tell us, did it? So N, D will represent that we don't know. Okay, so that's the first thing we would have to do moving forward in this calculation. So if you draw your gear train like this, you have done a good job, and you're ready to move on with the calculations. Okay, so let's move on, and let me erase some of this stuff off here just to make it a little easier to see. Get the drivetrain drawing out because you should already have that, but I'll leave this information in regards to C. So let's answer the question that it'll ask us in the activity. The necessary torque output for the system is 500 foot-pounds. What should the gear ratio of the system be? All right, well, so we got to figure out the gear ratio in this system. And remember, we've moved on to another problem now, so it's not 2 to 1 like we were looking at the others. It's a totally different gear system, gear train. So gear ratio is equal to, if we're looking at torque, we know the formula is the torque out divided by the torque in. Okay? So where do we have this information? Well, we know that gear ratio is at 500 foot-pounds of torque on the output. So torque out is 500 foot-pounds. What else do we know? Well, we know if we're looking back at gear A, we had a power supplied at gear A at 100 foot-pounds of torque. That's the reason we made this note down here earlier. So we know coming into the system now also it's 100 foot-pounds. Well, let's just cancel some of this stuff out, and we have a gear ratio of 5 to 1. So that would be your answer for example or problem, actually number 6, I believe it is in your activity. So torque out divided by torque in. We know what the torque out is supposed to be, 500 foot-pounds. We know what the torque in is from gear A, 100 foot-pounds. That 1 doesn't cross out, by the way. That's an accident. All right, so you cross that out, you have a gear ratio of 5 to 1 when you work through the problem. All right. Well, I hope you have fun with these calculations. And I sure had fun doing the video for you. And look for more of Mr. Molton's videos coming at you in the very near future. And I feel an Oscar and maybe an Academy Award coming. So have fun. Have a good weekend if it's the weekend. If not, we'll see you tomorrow.